Welcome to our laboratory experiment number 6, eigenvalues using MatLab. This activity will allow the student to implement simple power method using MATLAB, Freemat, Mathematica, or similar software. The objectives of our laboratory experiment is to construct function using MATLAB, demonstrate our understanding in eigenvalues and eigenvectors, understand and implement power method to find the eigenvalues of a matrix using software. Materials needed is MATLAB, Freemat, Mathematica, or similar software. The pseudocode can be found in Numerical Mathematics and Computing, 6th edition, Ward, Sheeny, David Kincaid, page 362. Further, demonstrate simple method using MATLAB using the following specifications. Calculate the eigenvalues of a user-defined function with the following specifications. Function, simple power, arguments y is equal tag a and tol, where a is the square matrix and TOL is the maximum tolerance. Put these codes on an M script that is loadable in MATLAB. The MATLAB function should accept the user-defined function as an input argument and produce a variable containing the answer. Okay, we are live. Okay, we are now on laboratory experiment number 6. So, as per the pseudocode, we've made this program. Okay, power method used in mathematics and numerical methods is an iteration method to compute the dominant eigenvalue and eigenvector of a matrix. It is a simple algorithm which does not compute matrix decomposition, and hence it can be used in cases of large sparse matrices. Power method gives the largest eigenvalue and it converges slowly. In linear algebra, eigenvalue of a square matrix is defined as a vector which points invariant direction under the associated linear transformation. If lambda be the eigenvalue of a square matrix A, it can be mathematically depicted as AV is equal to lambda V, where V is a vector called eigenvector which is non-zero. This vector V is said to be normalized if its coordinate of the largest magnitude is unity. Okay, hence this program. Okay, in this program, the matrix whose eigenvalue is to be determined is the input, and its corresponding eigenvalue and eigenvector is the output. As the program is executed, it asks for the value of the matrix whose eigenvalue and eigenvector are to be found out. After that, the input matrix is checked whether it is a square or not. If the matrix is not a square, an error message would be displayed. Further, the matrix should be symmetric or positive definitive. Then an initial guess value is to be given to the code, and based on that value, the following the theory, the program calculates eigenvalue and eigenvector of the entered matrix. Okay, I'm going to give an example on how this program works. Okay, say click run eigenvalues. We enter our matrix. So we input our matrix, say it's 1, 2, 3, 4. Close it with the parentheses. Enter. Okay. Suppose x is the eigenvalue. You will get this any initial guess for initial value. Say yes or no. Say yes. Initial guess for x. We input our guess. Okay, and the error, the TOL, or the error is allowed in the final answer. Say 0.05. We press enter. Okay, so we have an answer. It's 28.4286. Okay, the largest eigenvalue obtained after 3 iterations is 5.2857143, and the corresponding eigenvector is 0.4595 and 1, 28.4286. This concludes our laboratory experiment number 6. Thank you. Questions. Validate your answers using the function EIG. Did you come up with the same answer? Yes. Question 2. What could probably be the source of errors for your algorithm to diverge? Source of errors, I have seen no errors in my algorithm. So on to question 3. What could you conclude with this activity? So we learned how to script power code, and power method used in mathematics and numerical methods is an iteration method to compute dominant eigenvalue and eigenvector of a matrix. So another is that in linear algebra, eigenvalue of a square matrix is defined as a vector which points in invariant direction under the associated linear transformation. And what else? So I guess this concludes our video. Thank you very much.